For decades, the concept of interplanetary or interstellar space travel has been limited by fuel and speed. We currently use chemical propellants to travel the universe, and it is fast, but not just fast enough to get us to reasonable destinations within a short period of time. Very limited, heavy, and expensive. That's why scientists and researchers are working on more faster and efficient ways to travel the universe. In this video, you will see the top 3 interstellar space technologies that can reach near light speeds. Lightsail. As the name Lightsail implies, sailing through space on light beams. This is the kind of technology you would find in a good science fiction movie or novel. A light sail is a small spacecraft that has sails. When light reflects off the sails, it propels it forward. Now, this is how it works. Photons emitted from excited atoms in a laser have energy and momentum, which forms the basis of laser-based propulsion. Photons are released in a beam from a laser, and when they hit a highly reflective object, their energy is translated into a push that is capable of moving objects. With this technology, scientists imagine an array made up of a large number of amplifiers that sync up and act as one big laser, pushing our spacecraft to near light speed. In space, there is no friction or air resistance to stop it or slow it down, so it will just keep moving at a constantly high speed. The light sail is a very small satellite, very small and needs no chemical propellant. The sails are a micron thick and very reflective, so when hit by the extremely powerful beam of laser, it will start zooming across the universe at extremely high speeds. Since no chemical propellant is needed, the spacecraft will be very light and never run out of propellant while traveling through space. It can reach speeds of up to 25% the speed of light, or 75,000 kilometers per second. Using chemical propellant spacecraft, it will take up to 8 months to get to Mars, but for a light sail, just 72 hours, a few days to get to Pluto, and less than a month to overtake the Voyager, just 20 years to get to the Alpha Centauri star system. Just imagine this, it will take a whopping 75,000 years to get to Alpha Centauri with the fastest chemical propulsion technology we have available. But this doesn't mean it doesn't have problems. Number one problem is how to slow it down when it gets to the particular destination it is heading to. Since the spacecraft is not using chemical propellants, there is no recognized way on how to slow it down. Now that's where you come in. If you have any ideas on how it can be slowed down, please make sure to write a comment telling me how, because it will be really helpful. Solar sails. Unlike the first laser-powered spacecraft, the solar sail will be powered by energy directly from the center of the solar system, light from the sun. Now, this is how it works. Light from the sun blows the sail in space. Although photons have no mass, they can impact momentum when they bounce off a highly reflective surface. Here on Earth, you won't feel it, but in the vacuum of space, it will propel objects to incredible speeds. In space, there is no friction or air resistance to slow it down, so it will just keep moving and accelerating. A solar sail can reach incredible speeds of up to 6% the speed of light, or 18,000 kilometers per second. Actually, on the 23rd of July 2019, a solar sail was deployed into space by the Planetary Society, and it is currently in orbit, sailing in space and sending back images. Solar Electric Propulsion, or SEP. Also known as ion propulsion, this technology is replacing chemical powered thrusters with electric ones. Ion propulsion takes advantage of magnetism and electricity to push spaceships through space, and this is how it works. Electricity generated by the ship's solar panels or solar arrays gets to the power processing units, which gives a positive electrical charge to the atoms inside the engine chamber. They are pulled by magnetism towards the back of the ship and then pushed out of the ship by magnetic repulsion, pushing the ship forward. The best chemical propellant spacecraft have a fuel efficiency of just 30%, but ion engines have efficiency of up to 90%. An ion spacecraft uses the sun's power and can keep propelling itself throughout the entire mission, taking advantage over the chemical powered spacecrafts. Since no chemical propellant is needed, the cost is drastically reduced and efficiency increased. In the future, ion spacecrafts will be used for exploring asteroids and also human exploration of Mars. Now, that's it for today. If you learned something new today, please subscribe and click that notification bell so you won't miss another video. Make sure to like and comment on this video telling me how that light sail can be slowed down. Thanks for watching and see you in my next video.